everyone, and welcome to the talk on Ringo Transforming Tabular Data by Declarative Mapping, developed by Chen and his team. Today, we are going to explore how they tackle a big challenge in data work. Transforming raw data into a usable form is a big step in data analysis, often consuming a lot of time. This process is usually complex and involves many steps. Traditionally, data is transformed either manually or through specialized coding, which can be inefficient for large datasets and difficult for those who are not programming experts. Some modern systems offer tools to simplify data transformation, but they often struggle with complex tasks and rely too much on specific user inputs. Ringo, proposed by the author, is different. It uses a new way of changing data that's easier to use. You can just drag and drop things to change data, like putting stat, year, and GDP in the right spots on the table. Let's look at this figure. Ringo allows you to move data around a spreadsheet to make a new table. This means you can line up stat, year, and GDP easily, making a job that used to be hard a lot simpler. So Ringo works by using a bunch of tools that fall into three buckets: transform, separate, and combine. Transform tools change one thing into another. Separate tools break one thing into many. And combine tools put things together. For instance, splitting function in separate tools can split a string variable by a separator into a list of new variables. Now, if we look at this figure at this part B, it uses split to pull out stat names from a list, like Alaska is shortened to AK. Also, union puts 2 years pieces together, like gluing 2 lists into one, and the format changes a GBT number to look better. You can see from here. So for left part, Ringo tags for left part, Ringo tags out 6 pieces of information from 2 tables of data. It connects these pieces like matching 2004 from the year to Alabama and Alaska from the state and then to their GDP numbers. Now let's design Ringo's design and system setup. The design of Ringo is formed by 5 primary design considerations. We'll take a quick look at the system design and provide more details on how they meet the design considerations. Let's check the figure first. The system is built with 3 main views: row table, tag table, and suggestions. This provides data presentations, table composition, and transformation recommendations respectively. For design consideration 1, to support flexible construction of mappings, users can have direct and indirect mapping interactions. Direct mapping drag variables to table channels, immediately see the impact of their actions. Indirect mapping goes further by allowing for assembly of mapping through suggestions, facilitating a range of transformation tasks. For rule 2, fix ambiguities and conflicts in constructed mappings, which is crucial when multiple potential mappings arise. For instance, in this figure, dragging first level into the target table prompts Ringo to ask whether to map it to the row channel or to the column channel. This can guide users to make precise mapping choice. And for the third consideration, recommend for complete and incomplete mappings. Ringo doesn't just wait for users to finalize their tablets. It dynamically recommends variations and alternatives during the mapping process. Whether the table is partially complete or just starting out, Ringo's suggestions provide users with a spectrum of possibilities, encouraging exploration and discovery. To balance diversity and the exhaustive of recommendations, So while Ringo can generate an exhaustive list of table forms, it intentionally avoids overwhelming users with too much choice. Instead, Ringo recommends typical variations and alternatives that are most relevant, balancing the diversity of options with a cognitive load of the user. And the final rule, facilitate understanding and selecting of recommendations. Understanding and choosing from recommended transformations is made intuitive in Ringo, with natural language descriptions and the ability to hover and preview effects. As we see in this figure, users can effortlessly interpret recommendations and visualize the outcome, making informed decisions easier. Now here's a quick summary of what's new in the approach. Declarative mapping approach, interactive system for users clarify their interactions, flexible and user-friendly interface, exploration of table variants and optimization of the table layouts. When it comes to the evaluation process, they marked their study by bringing together 12 participants, each coming from diverse professional backgrounds and possessing varying degrees of expertise. This mix was crucial to ensure a robust test of Ringo against traditional methods. For comparison, they chose FALS, a well-known system based on the by-example approach, as their benchmark. The participants engaged in 4 carefully selected data transformation tasks, each involve crucial operations like aggregation, string manipulation, and table reshaping. This task was specifically chosen to challenge Ringo and test its abilities in scenarios that professionals frequently encounter. To ensure a structured and fair assessment, each participant went through a detailed tutorial to familiarize themselves with both Ringo and FOSS. Following this, they embarked on hands-on sessions with each system, applying what they learned in real time. We closely monitored key metrics during these sections, such as the time taken to complete each task and the number of interactions required, providing with a quantitative measure of each system's efficiency. The result of studying was quite revealing. Ringo stood out, significantly reducing the time and interactions needed to complete the data transformation tasks. This efficiency gain was not just a number, it was anchored in the experiments of the participants who found Ringo not just to be intuitive, but also highly adaptive across various scenarios. So currently, Ringo employs a modest implementation focused on a broad range of data operations rather than exhaustive coverage. This fundamental work has shown the potential of the system, but also highlights areas for growth. Expansion for functions. So one key area for future development is expansion of Ringo's functions. For instance, adding more complex operations like interpreting missing values or handling cross tabulations with hierarchy headers could significantly enhance Ringo's capabilities. So for future work, looking forward, we envision a more advanced interaction model. This could involve a focus on assembling examples with optimal mappings in a system that can recommend complete mappings and tables. Such an approach could make Ringo more intuitive and reduce the initial learning curve for new users. And the conclusion. In summary, while Ringo has already made significant strides in simplified data transformation, there is exciting potential for further